wait for a minute. We're going to wait for just a minute or two for people to file in. Where did Peter go? There he is. Okay. Well, people are still filing in. Do you think I should go ahead, Kelly?
Yeah, I think it's safe.
Okay. All right. So why don't we get started? It's my pleasure today to introduce Professor Peter Bruza. He's on the Faculty of Science and Technology at the University of Queensland in Australia. His PhD was in mathematics and computer science, and he's a pioneer in the quantum cognition literature. He's the co-author of the classic textbook with Jerome Busemeyer, Quantum Models and Decision-Making, or it's my copies at the office, actually, so I can't reproduce it right here. And Michael was saying that there are rumors of a second edition, so I'm interested in whether that's true, Peter. Peter's been a prolific writer in the field of quantum cognition and cognitive science, information retrieval, applied logic, semantics, contextuality and language, quantum game theory. There's all these different areas. 273 publications. Just mind-boggling. And interestingly, actually, he's also very, like Michael, a serious Buddhist, and has written a really interesting article that I had read before called Absolute Present, Zen, and Schrödinger's One Mind, which is just 2019. It's a really interesting piece. And so anyway, it's a very capacious mind here that we're going to hear from. And he's also working on trust and AI. And so that's obviously in the news a lot lately. And so if there's a way that we can somehow steer the conversation to that, I'd be delighted to do a tangent, even if that's not directly central. In any event, today, Peter will be talking about thoughts about what the quantum-like contextuality of cognitive phenomena might say about the nature of human cognition. Long but descriptive title. So, all right, Peter, please take it away.
Yeah, I'll okay, share the screen. I can't, oh, there it is.
Yes, now it works.
So can you see that now?
We see your titles, but not yet in the presentation mode. So we see also the preview of all the others.
Wait a minute. So wait a minute. What I'll do is I'll disable that other screen, and that should be all right. Is that better? Or is that still in preview mode?
Still in preview mode. Yeah.
Okay, use slideshow.
Mm-hmm.
That's it? Is that better?
Not yet. Let's see. Not yet.
Oh, wait, I'll try it. I'll try.
Yes. But, no, not yet.
Okay, I'll try this. Just let me get rid of that. How's that?
It's perfect. Now it's good.
Okay, so I think what I wanted to do with this presentation was a couple of things. The first is really to share thoughts, and the first word in the title is thoughts about quantum-like contextuality and cognition, because I've been investigating quantum cognition for a while, and just like in quantum physics, where you've got some core quantum concepts like indeterminacy, incompatibility, and contextuality, there's been a long, I guess, investigation and discussion, debate in quantum foundations about what those things, what they might say about what is the underlying quantum reality. And then so with these, in particular in contextuality, that's something that I've been really interested in for a number of years now. And I think the last time I presented here, I was talking about it. And we've been sort of investigating it, but there's always been this thing in the back of my mind about, if cognitive phenomena are quantum-like contextual, what does it say about the underlying cognitive reality? So that's sort of a question that's sort of been really in the background for quite some time. And then when Jerome and I started writing the first book, I wasn't, and we weren't really at a stage where we could seriously address sort of the deeper questions. And I guess those sort of questions are heading towards philosophy of mind. Is really what if we accept that quantum cognition is a viable field, and then a lot of the research that's been done has been developing certain models, et cetera, decision-making models, explanations of memory, et cetera. But when we move across into asking, well, what is the nature of mind, and what my quantum cognition say about that, then this is really an important, I think, theme or driving inspiration for this presentation. And also another thing that sort of driving it is I was really inspired by Michael's presentation about Buddhism, and so I wanted to sort of add on to the end some of my thoughts about I guess some aspects of Zen Buddhism and how that might be related to this question about what is the nature of mind, what is the nature of cognitive reality, those sorts of more philosophical questions. And so I guess I'm sort of asking for your open-mindedness, because when I mention thoughts, these are thoughts that I've collected, and I'm still sort of trying to arrange them suitably so that there is a coherent story to tell about these sort of more deeper philosophical questions. And by no means that I feel that I'm close to the end of it. So this is very, very much sort of like my musings around these things, and then maybe there's some of the things are wrong, or maybe they're misplaced, and even might be naive. So please keep that in mind as I go through this this presentation. So so let's see, 1 second. So as I've mentioned, the driving question is okay, if cognitive phenomena are contextual, what does that say about the nature of the underlying cognitive reality? That's that's really the core question behind this. And then if you start asking a question like that, is what philosophical position is appropriate? So this is one of the things that I've been grappling with, and to go back to the question about the book, we are preparing a second edition of the book, and one of the chapters is going to be about the philosophical aspects. And so this is something that I've been sort of looking at and trying to pull together, I think, some meaningful philosophical stances that could be related to quantum cognition and as it intersects with the philosophy of mind. And there's two that I'm going to put forward today. One is reality without realism, and this is just to give you a preview of what that is. This is Arkady Plotnitsky. He's a philosopher at Purdue, and he's an expert on Bohr's philosophy. And I think that this particular philosophical position really has some, I think, very interesting and I think relevant aspects to it to try and address this question: what is the nature of this underlying cognitive reality? And the other is really from this is from the Zen area, Zen Buddhist area. That's Nishida Kitaro, is a Japanese philosopher, and then I've been reading some of his material around something around the logic of nothingness. So towards the end, if there's time, I'm going to try and take you all through those. But just to set the scene, I wanted to just refresh your memories about contextuality. So these are just some points about that lead into what contextuality is. It's a concept that's really important in quantum physics. It has in the past, it continues to be extensively studied within quantum foundations. It's a subtle notion. It's something, when you read the literature around these things, there's really a lot of texture. There's a lot of sort of debate, different sort of positions on it, what it is and what it isn't. And then there's a really extensive literature around it. And there's been some very rigorous theoretical empirical methods that have been developed in order to study it. And sort of the Bell inequalities is just one example of that. But there's quite a lot of other things. One thing that we'll be going through this evening is the Coach and Specker theorem. I'm going to briefly introduce that because that's really one of the pivotal theorems in the area of contextuality. And the final point is that, within the field of quantum cognition, there's been speculation for some time that there has been quantum-like contextuality in quantum cognition, in human conditions, sorry. And Eddie Bar-Zafarov is also from Purdue University. He's been a real player in this area, and he's wrote a lot of articles about that and developed a particular theory called contextuality by default. But that's just one. It's a prominent way, but it's one way to view contextuality in cognition. And as I said before, the literature around this is really extensive. And part of the challenge that I've had in quantum cognition is really trying to communicate contextuality in a way that's accessible to people that are working in cognitive psychology, in order that they might be able to make an informed decision about whether that's something that they think is relevant to their research. So I just want to take you through just a little bit of quantum physics, and this is a well-known definition of contextuality. It came from Perez in the early 90s, and it sort of goes like this. Is part of the definition, but the crux of it, if you've got three operators A, B, and C, the operators are things that are used to model, quantum properties, and then it says if A and B and A and C, if their commutators are zero, that means that you can jointly measure A and B, and you can jointly measure A and C in some more sort of measurement context. But if B and C don't commute, and then this is the important point, then the result of measurement A cannot be independent whether A is measured alone or together with B or together with C. So the point about this is that when you're measuring, say, a certain property together with B, it's got to be different than when you're measuring A together with C. and this is sort of like this notion that the outcome of A is really dependent on the context in which it's measured. In this case, the context is another property that you're jointly measuring it with. And the other thing that I've got as a note there is that incompatibility is necessary for contextuality. So these B's and C's, they don't commute. That means that these properties B and C, you can't jointly measure, meaning you can't jointly or simultaneously establish the values of B and C at the same time, or in principle at the same time. And Krennikov has recently written an article. He's someone that sort of works in quantum foundations and quantum cognition and quantum biology, is a real all-rounder. And I'm very much in his camp where this incompatibility is a very, very important aspect of contextuality. And why I'm bringing that up is it's just more or less a tangential point, because there has been some proposals put forward that you can have a viable notion of contextuality when you don't have any incompatibility at all. But I think it's a very, very important and necessary condition for it. So let's sort of start with something that is very sort of well understood, and it's very common sense in the macro world. It's called non-contextual realism. And there are two aspects of this. One is that properties have well-established values at all times. And in the literature, sometimes this is called value definiteness, sometimes it's called determinism. But really, it sort of means that, you know, the phenomena that you're studying or exploring, at all times, even if you're not looking at them, even if you're not considering them in an experiment, the phenomena have certain well-established properties, and these properties have defined values at all times. And the other thing is that the value of a measurement of a property is independent of the measurement of other properties that are measured along with it. And this is the non-contextuality aspect. So so you can think about, you know, something like the moon. So, you can measure the diameter of the moon and its mass. So in principle, you could take those measurements, you know, simultaneously, or you could do, you know, the diameter first and then the mass, you know, and, you know, by measuring the mass, you know, it's not going to affect the diameter of the moon. And even when you're not looking at the moon, you're not considering it, it's quite reasonable to assume that, you know, that the moon has a diameter, a well-established diameter, it has a well-established mass. So all that means is, you know, when we talk probabilistically, you know, that the probability assignments are going to be context insensitive. So this example that I've got here of these this probabilistic equation here was taken from an article by from Potobsky, and he was referring back to George Boole's original paper from 1862, which developed a sort of logical algebraic theory of probabilities. And then when you go back to Boole's article, you know, he talks about an urn, and you know, you're pulling sort of balls out of an urn, and a ball has you know, a particular color. It might be white, and it has a, you know, the object, if you're pulling objects, it might be round. That's another property. And it might be of a certain substance. So this is you know, Boole was around in Victorian England, so they're, you know, you've got ivory marbles that you're pulling out of this urn. So what this means is that the probability signs are context insensitive. The probability is being white is equal to the probability that it's white and round, and it's white and not round if you're sampling. And that's also equal to the probability that it's white jointly with it being ivory, plus the probability of it's white and not being ivory. So that's really just an equation that sort of expresses that the probability signs are context insensitive, which goes back to this non-contextuality notion that, you know, you can this phenomena, like this object, has the probability white, and this is established. This is what it is, and it doesn't matter whether I measure its shape or its substance. That's really not going to have any effect on the value of it being white. So, like, if we take that into a more cognitive sort of setting, so you imagine a situation where you can measure the eye color of someone and then the size of their feet, and then you could also measure their height. But imagine that you can't measure all three of these things at the same time. You can only measure them, sort of two of them. So this goes back to this Perez definition that these two observables or these two properties can be jointly. We have that, and then we have, in another measurement context, we have the eye color and then their height. And you notice that the you notice that the eye color has changed depending on what other property that has been established with the size of their feet or their height. So to summarize that, the eye color changes depending on what property is jointly being measured with it. So that's its actual value is dependent on the measurement context. And the other important point about contextuality is that this cannot be reduced to a causal explanation, right? So this is something that we often assume at the macro level, that when we see these sort of changes, that we assume some sort of underlying causal explanation or phenomena at hand, so that there may be something about the size of the feet that sort of makes eyes blue, for example. And we've got here this incompatibility, is that we can establish pairwise measurements of these properties, but you can't establish simultaneous values for all three properties. So that's where the incompatibility comes in. So I want to now go on to sort of something a little bit sort of more deeper, and I want to illustrate sort of a very, very deep result and a well-known result around contextuality. And sometimes this result is illustrated using magic squares. So imagine that if we had, these magic squares, and in a particular cell, you can either have a 0 or 1. And then we have a number of conditions. So that the sum of the entries in each row is got to be an even number. So it's got to be, because you've only got zeros and ones, it's got to be a 0, 2, or 2. And the sum of the entries of the rows has got to be an odd number, so that, you can have a single one, or you can have all three ones in a column, and then you've got 3. So you can see here, if we look at the row at the top, we just got zeros, that's all even, so that satisfies the condition. If you look at the first column down here, we've got a single 1, so that's that's odd, and the second column is similarly odd, and then the second row is similarly odd. The question is that when you come down to this cell on the in the right hand corner, you run into a problem, because you can't satisfy the constraints of this magic square, because there are only 2 possibilities to put into this cell. If we put in a value 0, that means that this row is going to be odd, which isn't allowed. And if we put in the value 1, then that means the column is now going to be even. So how that relates to contextuality is the following. So you can imagine that the rows and columns are measurement contexts of, say, 3 properties of some cognitive phenomena. And this magic square demonstrates how non-contextual realism fails. So that the essential problem here is the assumption that the property that you're trying to or the value of the property you're trying to put in that cell in the bottom right corner has this pre-existing value 0 or 1. And also that it doesn't depend on what other properties are measured with it. And so that's why you get this contradiction. And so that so this is taken as a demonstration that non-contextual realism fails. So this is really, I guess, a simplified sort of explanation or intuition between a very famous result in the in contextuality by the Cognition and Specker that was proved in 1967, and is often it's often referred to in the contextuality literature. And so with that as background, we can sort of start to delve more deeply into what are the consequences of that. And so this is sort of an argument they took out of Herman's paper. And at a high level, you're trying to assess, okay, what are the implications of the Cognition-Specker theorem for quantum theory? And so that at the top, this is a conjunction of different aspects. The first QT represents quantum theory, or the axioms of quantum theory, which are assumed to be true, and from those axioms are certain theorems. So these essentially, QT represents all the truths that are sort of deducible from quantum theory. Determinism is that at each point in time, a property has a definite value. That's determinism, or value definiteness. Non-contextuality, that's been discussed before, that when you establish a value for a property, it doesn't really, that value isn't dependent of other properties that are being established or measured along with it. And you think about the moon as an example. And the fourth one is called the projection postulate. And this is not so relevant to the discussion that I'm bringing forward, but it's nevertheless important for the argument. So the measurement of a property at a certain time reveals reveals the value possessed by that property at that time. So in a sense, sometimes this is called faithful measurement. So in other words, that the values of the properties can be faithfully read off when you do a measurement. Of course, this can be debated, but if you assume all of these things as sort of basic sort of aspects, then what the Cognition-Specker theorem tells you, that when you form the conjunction of them, you end up with this contradiction. So that funny upside down sort of T is the logical symbol for a contradiction. And so that the Cognition-Specker theorem is really at the heart of this, because as I said before, what's generating that problem in the magic square is this thing that we, before we even look at the property of phenomena, it's got an established value, either 0 or 1, and then that's not going to be its value is not going to be at all affected by the values that have been established for other properties. Okay, so the question is, what do you do? So this is what the quantum physicists, we've got this this inconsistency that's sort of being turned up by the Cognition-Specker theorem. And how do you get rid of this inconsistency? So one sort of approach in the literature is you have to give up something, at least one thing. And a common way to deal with it is you give up non-contextuality. So sometimes this is presented in the literature. So, okay, you assume that the sort of quantum theory is consistent. So, and the projection postulate is really one that's can be debated, but is so often used in the computational machinery of quantum mechanics. The two that are up for grabs are determinism and non-contextuality. So one of them, at least one of them, has to be given up. And there is, I feel, there is quite an industry still in quantum theory that really wants to hold on to, I guess, aspects of classical realism that the phenomena that you're dealing with, they do have sort of definite values at all times, and the price you're willing to pay pay for that is to give up non-contextuality. So you're saying, well, okay, they've still got definite values. They've got this like the determinism, but now the values that you see are going to be sort of dependent on the context in which they're measured, and that's how you can deal with the contradiction. So how does that look like? So this is, how do we hold on to determinism in terms of this experiment we're doing? So before the measurement, the eye still has a definite, might be blue. And in measurement context 1 at the top, you measure the color of the eye with the size of the foot, and then the eye is blue. But when you get down in measurement context 2, you measure it with the height of the person, suddenly that the color of the eye is now brown. So this is how contextuality happens with it, while still preserving this assumption that the phenomena that you're dealing with have these well-established values of their properties at all times. So that's an introduction to some, I think, important aspects of quantum theory, and certainly when you're looking at contextuality, the Koch and Specker theorem is really, really essential results. But let's now move the discussion into quantum cognition. So what does all of this imply for quantum cognition? And so the first thing we have to state in this regard is almost like this assumption of analogy. So that I think a founding assumption of quantum cognition is that the assumption that cognitive phenomena are in meaningful ways like quantum phenomena. Okay, so now if we take that as a departing assumption, so we can revisit this inconsistency. So now we're talking about quantum cognition. So just imagine QC represents the formalism of quantum cognition that's just largely borrowed from quantum theory. It might have some adaptations, but let's just assume for the argument that it's consistent. And then now, what does determinism mean in this thing? So at each point in time, a cognitive property has a definite value. So, and this is, I think I would say a common assumption from orthodox cognitive science. So that when we talk about different cognitive states, the assumption that is widely held is that state has a definite value at all times. And then you would have non-contextuality, so that that you when you measure certain cognitive properties, its value doesn't depend on other cognitive properties that are established. And those of us who work in cognitive science certainly would say that this assumption is dubious. And nevertheless, in a minute I'll show you how we deal with that. And then there is the projection postulate is the same essentially as quantum theory. When you're developing formal models of quantum cognition, you're using this projection postulate as a way of formally getting hold of values of properties. That's how you model them mathematically. And so when you project, you're assuming that you're actually reliably getting off the value of the property. So that's the setup of the inconsistency. And the question now is that how do you deal with it in the quantum cognition case? And this is something that I've really been struggling with, about how to make, I think, justifiable choices in dealing with this inconsistency. And this was really subject of a paper we recently published in Cognitive Psychology, that the citation was on a previous slide. So essentially what I'm presenting here is a summary of that argument. And the crux of it is that we resolve this inconsistency by letting go of both determinism, and non-contextuality. So from a logical point of view, this is already can be contested. So usually when you want to get rid of inconsistency, you want to do it in a minimal way. And as I just presented previously, like in quantum physics, they let go of non-contextuality and keep hold of determinism. But as we go through this presentation, I hope I can convince you that there are reasons why it is justifiable to let go of both determinism and non-contextuality. So up the top, we can see that, this is how we resolve the inconsistency. So we've got quantum cognition. We assume indeterminacy, we assume contextuality, and we keep hold of the projection possibility. And then that's how we skate around the inconsistency of that's the Koch and Specker theorem puts forward to us. And what is indeterminacy? So that when we get up a determinacy, we assume indeterminacy, and then this indeterminacy is also a core assumption of quantum cognition, and really what it is saying that before measurement, the cognitive state is indeterminate, and it's important to understand what I mean by that. So indeterminate is really a form of ontological uncertainty. It's not an uncertainty due we don't know something about the phenomena. So it could be, and often in macro realism, we assume that a system, even it's a complicated system, and even some stochastic systems you can talk about in this way, that they actually have some underlying definite state, and we simply don't know what it is. So in such a case, the uncertainty is epistemic. It hasn't got to do with the very nature of the being of the phenomena that you're dealing with. Whereas ontological uncertainty, or the indeterminacy that is referred to sometimes in quantum physics, really means that the phenomena doesn't have any sort of definite state. And even if you had all information available to you, you wouldn't be able to determine what state it's in. And so that's the the intuition behind indeterminacy. So then before measurement, you have this sort of indeterminate phenomena, and then so you and that's the eye color. And then when it heads into measurement context 1, so now the eye is blue. And when it's measured jointly with the size of the feet. And in the measurement context 2, the eye color is brown when measured the height. And this is where the contextuality comes in. So this is, I guess, this is like a simplified but a high level sort of scheme to show how I feel that how contextuality and indeterminacy sort of come together within the framework of quantum cognition. And you can't see incompatibility here, but it's in the background because we can't measure all of those 3 properties at once. So we have to do that pairwise. So just to sort of move on to like how this may relate to empirical matters. So what is commonly done is that if you have a measurement context, and you sort of you run some sort of sampling, and then what you do is you form a joint distribution from this measurement context that sort of measures the eye color and the size of the feet, right? So you have a lot of people coming into your experiment, and measurement context 2, you've got the eye color and the height, and then the third one that you need to bring in is you measure the size of the feet and the height, and you also form a joint distribution. So the incompatibility between the properties doesn't allow you to form a joint distribution across all 3 variables at once. Now, the interesting thing is that when George Boole wrote his original paper in 1862, he, as I said, he was using logical algebraic relationships, which were prescribing, sort of mathematical relationships between relative frequencies that you're pulling sort of objects out of an urn. Sometimes it's white, sometimes it's white and round. These are all these probabilities we see in this red circle, and they have to adhere to certain inequalities. And Boole, what was really quite striking about Boole's article is that he was talking about the direct experience. So he was saying that these sorts of inequalities are what he termed conditions of possible experience. So what he was saying is that if something does not adhere to these inequalities, it's not something that's possible to experience. And so, like, sort of reflecting on this, I did some reading around. And when you look at Boole's paper, he's a realist. And, when you're talking about Victorian England, it's the time that, he was writing such articles. Realism was the dominant view. So, for him, it was quite normal to assume that before you've got an ivory ball in the urn, and before you even pull it out of the urn, it still has that property of ivory before you've looked at it. It's simply by looking at it, you're establishing its property. And the very establishing it is really the experience of the ivory being manifested at that point of measurement. But it has that property before you even look. So this is how, how realism sort of was baked into probability theory in the 1860s. And one of the points of this article that we wrote in Cognitive Psychology is the following: is that Boole's probability theory is mathematically equivalent to Kolmogorov's theory that was developed some 70 years later. And so what you can conclude from that is that the realism that sort of crept in was at the basis of Boole's probability theory is present in Kolmogorov's theory that we use now, and is, when we talk about Bayesian cognition and Bayesian models, that's in there as well. So, one of the questions we raise in this article is that, okay, if realism is sort of baked into the probabilistic tools, that assumption of realism, that properties have well-established values before measurement, and then, that we can have in certain circumstances context-insensitive probability assignments, which are also baked into this. So, and if you get phenomena that don't adhere to Boole's conditions of possible experience, so what does that mean? What does that say? And that can happen. So this is what another article I put in the citations is a really, really wonderful article by Itamar Petovsky, which he talks about quantum phenomena and Boole's conditions of possible experience. And also when these quantum phenomena, they don't adhere to Boole's conditions of possible experience. Yet they're real actual phenomena that can be measured. And how that happens is that, you test these inequalities, and then under certain conditions they're violated. And then Petovsky calls these inequalities the Bell-CH inequalities, and I think it's right he does that, because Boole was actually putting down sort of like the forerunners of the inequalities that were used in modern day quantum physics to sort of establish entanglement and things like that in quantum systems. And even I've seen some literature around that there was another Russian mathematician that may have been in I think the 30s or 40s that also had come up with similar inequalities. So I guess this notion that we have empirically we collect certain data in this case 3 pairwise distributions, and you're asking the question, can I join those three pairwise distributions together and to form a distribution across all three. If that's the case, then we're dealing with the normal realist probability theory. But if not, we're dealing with a phenomena that's outside what George Boole would say in the 1860s, the conditions of possible experience. So then the question then arises is why can't the joint probability distribution be formed? And then what might that tell us about the underlying reality of the cognitive phenomena or the quantum phenomena, for that matter? And this is where I really appreciate Inema Potofsky's thoughts on this, because Potofsky was like really mathematically gifted, but he was also a philosopher. So, you know, when you read his paper, there's some mathematical arguments in there, but he's really quite sharp, and I think quite very, very thought-provoking in terms of his reflections and his conclusions about, okay, when this joint distribution can't be formed, what's actually going on? And I wanted to share some of the thoughts that he had about that. And so there's a couple of quotes out of the paper from Potofsky. He said we may attribute this failure to wait a minute, sorry about that. To the often implicit assumptions that there exists a well-defined distribution of properties over some population, and the results of our measurements really reflect this fact. So that first sentence is really what he's saying is really think about an urn full of marbles, right? So when we're sampling from that, we've got red marbles in there, we've got blue ones, we've got white ones, etc. So that we've got some distribution of colors, say, over the population. And we're sampling, and the results of our measurements that just merely reflect, this distribution. And when you test Boole's conditions of possible experience in those settings, the inequalities are all adhered to, and then we're dealing with common sense reality. And it's sort of like in George Boole's terminology, this is the world that we can experience from a realist point of view. But he said, but then Potofsky says, well, maybe there is no population, okay, but and even if there is, and this is the important point, there are no well-defined properties existing independent of observation and distributed in a specific manner. So here is clearly saying, okay, so the phenomenon that we're dealing with is now not this value definiteness of determinism is something that's not is not happening, so that it doesn't have well-defined properties. And then he goes on, he says, and then all that exists are the phenomena themselves, which simply occur without cause. So he's saying, okay, that so when we're going outside of Boole's condition of possibilities, so what's happening there is that these phenomena are appearing. Yeah, they don't have well-defined properties in advance measurement. They appear, and they're appearing they simply occur without cause. So you can think about in entanglement experiments. You've got two measurement settings across from each other that are sufficiently separated, and you're measuring, say, the spins of quantum phenomena on one side and on the other. And what you can get is correlations between these phenomena that exceed classical bounds. But according to Potofsky, is that these phenomena are simply co-occurring. And this co-occurrence, these correlations do not have an underlying cause. And then this is very this sort of giving up of causality is very much, I think, something that I subscribe to, but also a lot of people in quantum physics, that there is a problem with when we think about causality in terms of quantum phenomena, and it's quite often that people adhere to the stance that there is no causality. There are correlations that simply do not have a causal basis, and so Pitofsky is certainly in that camp. And then finally, he says, and this is an interesting point, and this is getting to where this presentation started, when we're looking at what is the underlying reality of this. So we don't have well-defined properties. There's no causality. So all the things that we're sort of used to are sort of slipping through our fingers. And so what are we left with, really? And he said that, well, there is no deeper reality which causes them to occur. And the phenomena themselves are their deepest explanation. So this is, so what Pitofsky is reflecting on, what's the nature of reality when these pools of conditions of possible experience, or the Bell and CH inequalities that we test empirically, what is the nature of the reality that's causing that, or is reflected by those conditions of possible experience being violated? So to summarize Pitofsky's position, he embraces indeterminacy that we saw before, and acausality in relation to the underlying quantum reality. And also this point about there is no, so we can't get access to some sort of deep reality, certainly can't sort of, so it's not really there. And we can't say much about that reality. And this is where I found that Pitofsky was sort of, without citing Bohr, had some similar sort of views about this sort of reality, not totally the same, but certainly some marked similarities. So this is where I'm going to connect Pitofsky's intuitions that I just presented with this philosophy, reality without realism. So as I said in the introduction, this is Arkady Plotnitsky's sort of characterization of Bohr's position. And I want to take you through some basic elements of that too. Plotnitsky's written a book about it, and he's got several papers about it. And I think for those that are interested in these things, I think it's really worth reading what Plotnitsky has to say, because Bohr is, when you read some of Bohr's works, they're really quite opaque. And it's good to have someone like Plotnitsky around, who is sort of spent a substantial amount of time in his career to try and understand what Bohr was saying, and sort of translate that to us, so we can sort of understand better where Bohr was coming from. So I hope with the next couple of slides I can give you a sense of where Bohr was coming from. And you might also, when you see these things, you might also understand why his position isn't at all popular, particularly towards the end. So these days, I don't think there are many that sort of really in Bohr's camp in relation to his views about the underlying reality. So reality without realism. So what is that? And so the first thing is that you assume that there is some sort of reality. Okay, so it's not an idealism or anything like that. There is a reality. But the point is you don't make any assumptions concerning the character of this existence, of this reality, or what it means to exist in this reality. So what allows one to place this character beyond representation, or even conception. So like, just to give you an idea of, why Plotnitsky might sort of associate something like that with Bohr. This is a quote from Bohr. So he's talking about, blah, blah, blah. In quantum mechanics, we're not dealing with an arbitrary renunciation of a more detailed analysis of atomic phenomena. So he's talking about the quantum realm, but with a recognition that such an is in principle excluded. So it's not saying that, at this point, we don't really have, haven't developed a detailed level of analysis. It's just not possible to get there. And then this is where I think that there are some interesting things to say about, how quantum reality sort of differs from, you know, the sort of like the more macroscopic realities that had been sort of dealt with up in science up to that point. And the first is this issue of representation, because a lot of science up to the point of quantum physics. So when you're developing a scientific theory around some phenomenon, the formalisms that you're dealing with sort of have this thing where that they when you say write down a formula, that what you're representing is you're representing some aspect of that reality. All right, so that's the representational part of that. And then the other thing is, you know, that you when you're using those equations, say for example, or those models or theories, you use them to sort of come to know something or about that reality, or you come to conceive something about that reality. So Bohr is saying, you know, in the weakest form, he's saying when we're dealing with this quantum reality, it's beyond representation, which might seem strange for those that are, you know, use the quantum formalism. So when we write down the state vector, for example, in some formal quantum model, isn't it that we're representing some aspect of the quantum reality with this state vector, you know? And then there's a view that we're not, that state vector doesn't have the status of any representational status of that reality. All it is simply a predictive mechanism. So this is Michel Bitbol has written a paper about this, and I'm sympathetic to his views on this. And the other is, you know, this is, I think, echoed, you know, when Bohr says it's in principle excluded. We can't conceive of it, so we can't represent it in the strong form of reality about reason. We can't know anything about it. We can't conceive what this reality is like. All we can say is that, you know, it's there. And then what its character is, you know, this, you know, we don't know. And this sort of echoes Potofsky's. It's just all we've got access to is the phenomena themselves, and you know, there isn't a deeper reality that's sort of lurking in the background that's causing them to happen. And I think this is quite you know, controversial in a sense, because you know, a lot of what we try to know about reality historically in science is via causal relationships. And this goes back to Potofsky's thing. When we give up causality, we're giving up a really, really important foothold to try and understand something about that reality. And if it's not causal, then we've lost, historically, certainly in science, a very, very important tool for us to come to grips to know something, conceive of that, what the reality is that we're interested in. And this is another quote from Politsky. So for Bohr, then, quantum mechanics was a rational theory of something that is irrational in the sense that it's being inaccessible to a representation or knowledge, or even to thought. So this is, you know, maybe to those listening might seem, you know, quite provocative, because, you know, we've developed this theory, you know, quantum physics, you know, we develop lasers, and, you know, we can understand how stars form, etc., etc. And Bohr's saying, well, when we look, you know, at the theory, it's you know, it's the reality that quantum mechanics is being developed for is beyond representation, and we can't know anything about it. So it is a radical position, but one I think that I am personally aligned with, and I'll try to explain as I go through why that the case is. And so this is once again to remind you that these are just thoughts that are that have sort of I've been pondering for some time, and they come not only from my sort of investigations and my career as a scientist, but also in my Zen practice. These things also come up in a different context, and so I want to actually try and I think in sort of inspiration of the presentation that Michael gave, to try and say something about how these two aspects can be integrated in this context of reality without realism. So just to summarize that, so realism, there's no causality, there's no pre-existing properties, just in independent observation, it's indeterminacy, and then contextuality is automatic in that theory, they're just detail. And this is this quote, well, from Petrovsky, that these phenomena simply occur and that's it. And then the properties that do that are contextual and they're beyond representation and even conception. So if we take the strong form of reality without realism. And so the thing that I've been thinking about is that when we talk now about cognition, when we talk about phenomenal properties that we experience, like through, for example, through perception or different sense organs, are these fundamentally non-representational and beyond conception, assuming that these phenomenal properties, which I think are like the quantum properties that don't adhere to Bool's conditions of property experience. So I believe that Bohr's reality without realism is a worthy philosophical position for the phenomenological aspects of human cognition. And the next slide, I want to sort of make that point a little bit more detailed. So, sort of the dominant view, I would say, in cognitive science or cognitive psychology is the computational mind. And so what is that? Well, it's essentially that human cognition is a computational device. And so and because it's computational, it's computing with representations of, say, cognitive properties or states. And usually it's assumed that these representations are internal, somehow of an external reality, and cognitive functions are driven simply by computations, because there is no computation without representation. And as I said before, it's common to assume that these cognitive properties are determined. They always have cognitive properties, or cognitive states are always definite, have well-established values. It's Cartesian, so we assume the mind operates within the bounds of the brain. This is where causality is at play, and context sensitivity, because context sensitivity is a sort of derivative of causality. And then you can talk about, this is really, if we talked about realism before, you can talk about a cognitive realism. So if you talk about the underlying philosophy of the computational mind, I would say that it's a form of cognitive realism. Now, the other one that's of real interest to me is the phenomenological mind. And so, what's that? In contrast to computing, these are it's experiencing, direct experiencing, and what we're experiencing are phenomenal properties or phenomenal appearances, and these are non-representational entities. So there is a big, in philosophy of mind, there is quite a lot of literature around, whether the status of representation in the mind, and whether, for example, perception is dependent or mediated by some representations or not. And I take the view, at least for a large part of the phenomenological mind, that the phenomenal properties, these quantum-like contextual properties, they're non-representational. So this is going sort of linking back to the weak form of reality without realism. And these phenomenal properties are indeterminate, as I've showed before. And rather than being Cartesian, this is really embodied in an active. So these are embodied in active aspects of cognition. So the human agent is directly experiencing the environment, and this is coupled with it. And there is no causality, and this is where contextuality has a role. And this is where reality without realism, I think, is a viable philosophical position. And is it strong or weak form? I'm predisposed to thinking the strong form is viable here, and I'll try to justify that as we go along. So in the last part of the talk, what I wanted to do is try to integrate this sort of reality without realism. So there's this view of quantum reality with the experiential reality that I just described of the phenomenological mind. So you might think that this is a really hard ask, and it is. But I nevertheless think in these thoughts, again, I remind you, these are just thoughts of mine, and then I haven't got sort of well worked out arguments for this yet. But on the left-hand side, what that funny diagram is trying to represent is that we've got sort of this yellow area is some sort of quantum phenomena that is subjected to, for example, a fermion or some electron. And then you can choose an axis in which to measure it. So you can measure on the X direction or the Y direction or the Z direction. So these things here represent sort of like measuring devices. So if I choose to measure this electron at the Y direction with this measuring device, then it'll come back with its spin up or spin down. And this is the one that's observing whether you see spin up or spin down on the measuring device. And similarly, you could choose in the Z direction or the X direction. You can measure it. So that's this is an example of how we can explore the quantum reality. And then Bohr would say that this thing here, we can't know anything about this. We can't represent it in any way. So all we can do with the measuring device is that he would say that there is some underlying quantum reality that interacts with the measuring device, and then we see as an appearance some actual reality. There is spin up or spin down. But he would say we can't even say that spin up, spin down is actually a property of the quantum reality. All we can say is that there was an interaction between that and the measuring device, and that property is something that's come out of the interaction. So he's really quite conservative in what it is to say. And then quantum mechanics really has only anything to say about that aspect of it. It can't sort of penetrate deeply at all. You can't even penetrate at all into what the nature of this underlying quantum reality is. And the right-hand side is reflective of this experiential reality. So we see, as an experiencing agent, for example, we see a beautiful image of some mountains and a river and a moon. So how is it possible to sort of say something that might bring these seemingly two very different realities together? And this is where I want to sort of share some thoughts about the logic of nothingness. By the way, how much time have I got to go? I've lost track.
Not a whole lot, about 20 minutes.
Okay, so yeah. Okay, so okay, I'll try and sort of. I've only got a couple of slides yet to go, so I'll try and get through this and then open it up for questions.
Okay.
I think this is so this sort of tries to sort of bring sort of some of the Zen Buddhist aspects of this and trying to bring them across into so saying something about or some connections with an underlying quantum reality. So so this is calligraphy that I got from when I visited Kyoto a couple of years ago. There is a very old Rinzai Zen monastery there, and then I picked up this calligraphy, and it kind of looks very simple, but the important thing to understand about this calligraphy is it really has a quite deep meaning. So this circle here sort of represents sort of like the ground of reality. And note, inside of that, there is nothing there. It's empty and it's an empty space. And out of it, this triangle represents a form that is emerging out of this empty space. And as the emergence goes on, the forms become more complicated, so the triangle becomes more square. But the point is that there is this aspect of nothingness or emptiness, which is the ultimate ground of reality. And within Zen Buddhism, sometimes this is talked about, but invariably when it's talked about, the language is contradictory. So when you're referring to this, when it's referred to this sort of space here, empty space, it's neither being nor non-being, right? So it's neither existence nor non-existence. It's neither something or nothing, and it's the form of the formless. So that there are all these contradictory expressions to try and refer to that. And so these when you think about them and consider them with your intellect, they're in a way, because they're contradictory, they're what they're referring to is beyond conception. There is anything, these contradictions, anything that you try to sort of hold on to conceptually, whether whether it's being or non-being or absence of being, it's all denied. So it's all taken away from you. And so that it's the purpose of these sort of expressions is to say that this is really beyond the intellect, beyond conception. But you have similar statements in quantum physics. So when you're talking about this indeterminacy, so if you have some quantum system S, and this is a statement I got out of some paper, the system S is neither in state sigma nor not in state sigma. So when you look at that sort of intellectually, so well, what state's it in? It doesn't make sense. So once again, what has been pointed to that in indeterminacy, that we can't really get a hold of it, of what it is from a conceptual point of view. And this goes back, I think, echoes back to what Bohr was saying, that it is beyond what we can conceive and beyond what we can know. So then this logic of nothingness by Kitaro Nishida that I mentioned before, just want to sort of briefly introduce that because the Kitaro Nishida was a Japanese philosopher. He set up the Kyoto School of Philosophy. And the interesting thing about Nishida was that he was a Zen practitioner, and D.T. Suzuki in one of his books said that he had an enlightenment experience in his Zen training. And what Nishida tried to do essentially is that the experiential insights that he gleaned from his practice in Zen Buddhism, he tried to make accessible to a philosophical audience. And then he talked about, and this particular school talked about this logic of nothingness. And then it goes like this. It has one rule that's called the sokai in Japanese, and it has to do about identity, and it goes like this: A equals A. And the sokai is this red thing here, and A is immediately not A. Therefore, A equals A. So this is what has been called the logic of nothingness. And in Zen, this type of contradictory reasoning has been around for a while. So there, to go back to this scene, so there is this teaching, the Wudang Huyang from 1252, says the statement, mountains are mountains and rivers are rivers. And then the next statement is mountains are not mountains and rivers are not rivers. Therefore, mountains are mountains and rivers are rivers. So you can see that on the left-hand side is more the abstract representation of this this type of like at surface value contradictory statement. Now you can, it's important, I think, to sort of place this into context, you know, that how these things are investigated. And this is where now I'm going into my experiences in Zen practice. Now, like if you look, so, you know, a common way that we view reality is that we objectify it, right? So and so when we view, say, a scene, or when we see something, we usually categorize it and break it down into these objects. So then, you know, we've got a mountain, we've got mountains, we've got rivers, we've got trees. And when things are broken down into objects, you know, so a mountain is a mountain. So A equals A. You know, a cup is a cup, a keyboard is a keyboard. You know, there is no denying that identity. But the one that there's a problem with is the one that it's immediately not that. So the Sokohai is that at the same time, a cup is not immediately not a cup, a mountain is immediately not a mountain. And this then, I think, in terms of any view of objective reality, this is what delivers the contradiction. And it's interesting, you know, like when we wrote, it was mentioned before about this article we wrote about, you know, Zen Buddhism and Schrödinger. Schrödinger has a wonderful article called The Principle of Objectivation. I think he wrote that in the 1940s, and he was reflecting on the scientific method. And there was a point, like, you know, we normally assume, science normally assumes that the reality that we're dealing with is an external reality of objects. And then there are objects and how these objects are related to each other. And that's essentially how we can come to understand the nature of that reality. And then Schrödinger said something I always remember very radical in that article. He said, okay, so what happens is that what we, you know, when we're observing something, we step back as an onlooker. So there's a subject of cognizance sort of steps back, and by that, as an onlooker, and he says by that very process, the objective reality is born. So it's not that the objective reality is the real one, it's this stepping back as an onlooker that is, in the human sense, we're viewing reality behind, you know, through our two eyes, and we assume there is this external reality out there of objects. And the reason why Schrödinger was saying that it was when quantum mechanics was first being discovered, they thought because the way or how the measurement process worked, and it was raising some interesting sort of quandaries that, you know, it seemed like the very act of measurement was creating the reality. That there were some that thought at the time that quantum mechanics might be able to say something about the age-old problem of subject-object duality. And in this very beautiful article by Schrödinger, he said that that's not the case. He said because there is no separation between subject and object. And so he says we're not rigorous about when the subject of cognizance steps back as an onlooker and the objective reality is born. There is this inherent separation that seems to be there, but he said that in reality it isn't. Now, so how do we make sense of something like this mountains and rivers argument or teaching? And then there's another way that can be explored, and it can be explored at a very direct experiential level that is beyond the intellect. And this is what so much about what Zen training is about. So that you can, I don't know if you've ever had that when you've come across, say, a very, very beautiful scene, right? And for a moment there you're stunned, right? And you forget that you're there. so there's only just the direct experience of viewing that scene. And then I don't know, in these circles there's sort of an unorthodox sort of Zen teacher that did teach at Cambridge at some point, called Douglas Harding, and he describes, when he was in India, in the 40s, that he had this amazing experience, just much like this. He was up in the mountains some way, and he looked out across a scene where he saw these mountains. But what happened isn't what normally happens to us, where this onlooker that's looking out on the scene and the following Schrodinger, we're sort of tacitly or even consciously rendering that scene as something involving objects. He sort of said that what happened is that he noticed that where his head was, what you normally think where your head is, was just simply empty space for the reality that was emerging. So it was just this awareness of the scene, a direct experience of that reality. And so that when he was describing it, is that the awareness sort of arises with that which is aware of, so that yes, in that experience there is mountains and there is rivers, but there is all this there's also this aspect that there is this, he said, that where his head was empty, this empty capacity where there was no sense of self, there was no sense of his me or I. And so what he discovered was that awareness that arises, which is aware of, is awareness itself. In that sense, so then they are not mountains and they are not rivers. And then those two together at an experiential level, then you can conclude, therefore mountains and rivers are rivers, but not. There is no subject-object duality in that. So you are the mountains and you are the rivers. There is no separation from them. So this is at a Zen level. This is a way to come to an experiential understanding of what these teachings refer to in an intellectually contradictory way. So to go back to Nishida's logic of nothingness, it shows that what he was trying to show is that it's possible to speak about the ultimate ground of reality without objectifying it. So then there is no subject, there is no object. Or the flip side of that is that subject and object are one, which was Schrodinger was saying in his article. But if you have to say something about it, then it's necessarily contradictory. And so this, I showed an example in quantum theory when we're talking about something being in a state sigma and not being state sigma. So we have similar contradictions when we're talking about the quantum reality. So that's why it's some reason to believe that this ultimate ground of reality in both cases, in the experiential way that's presented by the Zen teaching and also what has been shown in quantum mechanics, that there is this fundamental ground that is beyond conception, beyond representation, and then can be described by this logic of nothingness. So I'll finally sort of close with this, so that with this integration, one way to think about this, and this is coming from the Zen Buddhist thing, is that this nothingness or empty interpenetrates form. So in that calligraphy I showed that we had this empty space and yet there were forms. So that in both cases, when you're doing measurements in quantum physics, so that we have forms that appear, and these might be sort of like spin up or spin down things on a dial, for example. But that form is interpenetrating with this underlying nothingness, which is referring to this reality without realism. This is something that we can't represent, that we can't conceive of, and if we talk about it, it has to be necessarily in contradictions. And then there is just a slight, the Heart Sutra, which is a very important sutra in Zen, and there's this line like emptiness is not separate from form, form is not separate from emptiness. So that these are not two things. The emptiness and form, they interpenetrate with each other. And so I think within the phenomenological mind, we have phenomenal appearances, which are the happenings, which are the forms, but they interpenetrate with this ground of nothingness. So the aspects that we can't know experience what it is, and we can't even represent it. All we have access to is what Ptolemy said, these phenomenal appearances, but they are not on their own, that they interpenetrate with this underlying emptiness. And the same thing is when we're interacting with quantum reality. And so I'll leave it there. And sorry I went on for so long.
Thanks, Peter. It was definitely worth it. So, and we started a bit later. So I would suggest that we can eat like 10 minutes into the break too. Just a question before, given the time difference to Australia, Peter, will you be able to join our open discussion, which will start after Dominic Widow's talk, in 2 hours, I think 2.5 hours from now. It will be in the midst of your night.
Yeah, so it'll probably be about 3:30 in the morning. So I don't think I'll be able to. Yeah. Okay, I'd like to, but I don't think I can make it.
So let's take good advantage of the maybe 10 or so minutes we have. So, and I would also invite people from the panel to just raise their hands and ask questions, because I think there's a lot of parallels also with Donald Huffman's way of seeing these things. I will just start maybe with one question or a comment from Matt. So Matt wrote a lot of comments, but they are all very technical in nature. And given that we have not much time, I would just mention his last comment he made, which I think it's interesting. So according to Webster's definition of perspective, it may be relevant here. It is the way of looking rather than the actual view produced by looking. So, just as a comment.
Yep.
And Patricia Lather is asking, then Buddhism shares neither nor thinking or deconstruction. What are the differences? Becomes interesting question, especially regarding reality part of reality without realism, outside linguistic paradigm or deconstruction into a sort of measurement paradigm that is itself both chimera and embedded in and emergent out of context. Non-dualistic awareness, experiential knowing, ultimate reality without objectification that embraces contradiction. Then no, I don't know.
Have I got it? So
yeah, okay.
That's Patricia's question. Neither nor thinking or deconstruction. What are the differences? Become interesting question regarding reality, part of reality without realism, outside linguistic paradigm, the sort of measurement paradigm. There's both chimera embedded in emerging out of context. Non-dualistic awareness, experiential knowing, ultimate reality without it, that embraces contradiction. Yes, that summarizes what I was trying to say. Phenomenon interpretation with ground of nothingness. Yes, that's right. Yes, I agree.
Maybe while we are waiting for questions from the panelists, maybe I can ask something regarding your first part of the talk, and that the combination of experiences of what can be experienced and what cannot, and to use this as a fundament of describing what is statistically describable or conceptually describable or not. I wonder whether at the end we are talking about two types of experiences here. So like one way of experiencing which still tries to put into concepts, which still tries to conceptualize, and one level of experience which even gives up on this. And maybe that something more is accessible and possible when one gives up of any intention to break it down, to project it down, to describe.
Yeah, I think I agree with that. I think it's the latter is necessary in order to understand the mountains and rivers. If we try to understand that, even imposing even lightly concepts, then we cannot get access to what that teaching is pointing to. This is, like what comes up. I remember when I was reading, Rara Thompson and Roche's book, the embodied mind. They in there they said that, that the Buddhists have been doing phenomenology for 2,500 years. So in a way, these Zen practices, or these meditative practices, essentially have the same. They're involved with the same investigation. What is the underlying reality? Is to penetrate what that is, to come to understand that, but not at an intellectual level. It is through direct experience of it, and then that. But then that experience. So when as soon as we describe it, it's gone. This is this thing that I think is so aligned with this reality without reason, that the quantum reality it's in the same thing. Is as soon as we describe it, it's really, one would say this is not what it is. So I think that's I think an interesting correspondence in my thinking. So did that answer your question, or?
Yeah, I think so. And then the follow-up question would be, which is also relevant to this workshop, is what would be the implications for social science, like the way we should look at problems in society and solve problems?
Yeah, I think that's a really, really good question, and one that I've always sort of thought about, because when a decade ago I had an interaction with a wonderful quantum physicist, Shimon Marlin, who wrote a wonderful book, Nature Loves to Hide, which was describing quantum physics from a Western philosophical perspective. And in that book, I came across these these writings of Schrödinger that I don't think too many people know about. What he was saying about this subject to object duality, and that subject and object are one. These are almost like New Age statements. And I was so, I was so surprised by it. I remember contacting sort of Michel Bitbol, and asking him, because he's an expert on Schrödinger. He wrote a book about his philosophies. I said, but what did people say? Like, what did other physicists say when Schrödinger was writing these things? And when you think about it, at that time, he already had his Nobel Prize. His exalted place in the history of science was already established. And Bitbol told me, he said that, they would frown, or they didn't, not even he could say those things, so that he was essentially, these sort of things he was ignored. And I think that I think in my discussions with Marlin, and the third part of his book, he calls the physics and the one. And I think that what we need to be able to do, he said, in quantum, the measurement problem in quantum physics is really something that we can't easily do away with. We need a really radical shift in perspective. And he said that will probably come about when we get beyond the subject-object mode of investigation. And I think this is what we need to be able to do in all areas, to find ways in order to do this. And then I said to him, does that mean that we have to get physics students doing meditation in Physics 101 or something like that? And he laughed. But I think it's an interesting question, because so much of how we do things is either explicitly or implicitly based on some subject-object mode. And then we render the reality into these objects, and then we're no longer in the logic of nothingness. We've lost that ground that Bohr is pointing to, that we can't know about, we can't talk about, except in contradictions, we can't represent. And I think it's being in touch with that that is really, really important in order to be at the basis of such investigations. But how to do it, I would, I have no idea. Yeah.
Thank you very much. In the meantime, Catherine Schaefer extends her gratitude to your talk, given that it's so late too. Then there's a anonymous question which connects to what you were just saying. Coming from the neither nor perspective, how would you describe what classical scientific disciplines are doing today? We have 3 minutes left.
So coming from the neither nor perspective, well, I still think they're fundamentally not in touch with this reality. They're not based on or in touch with this reality that we can't say anything about. And I think, and quite a lot of my readings in quantum physics is still trying to hold on to those classical aspects of that reality, and because there are good reasons for it, because it's been highly successful. But I think it's missing a crucial element of it, and so I think that the classic scientific disciplines, aren't really fundamentally based on that ground that I think need to be based on that ground in order to, I think, certainly to be experientially valid. That's coming from a Zen perspective. Yeah, we can develop about conceptual frameworks that are successful or whatever, but in the end, they're just structures made out of cloud stuff, and their connection with the essential basis of reality is tenuous, if at best, in my opinion.
Okay, thanks so much, Peter. If there's any last question from the panelists, unmute yourself and ask.
I just want to thank you, Peter, for the extremely beautiful talk. And as a person grew up in Oriental, in China, and I'm not a very serious practice of any religion, but I read all the literature, and I think I wonder, one of this maybe linked to all those questions here is that, again, using Professor Don Hoffman here on the panel, some metaphor about, we just have this cheaper headset, this cheaper interface we have, like those natural language, even we have to use with this addition of logic of nothingness, still relying some of the current simple systems we can use. We're just limited with those things. Like, it's so beautiful, but I feel like we feel this all the time, but as scientists, like in the daily life, you get a student graduate, you need to do this work and that work. Even for example, like a simple example, like this perspective question comes from the audience, from Matt here. It's so well studied in a lot of psychology, communication, a lot of theories kind of touch that, the theory of mind, perspective changing, and so on. But of course, studied in this classical sense. But even if we do this kind of work, or some projects we have done using the quantum model, again, it's so limited. It still doesn't catch the richness of it. So it's ultimately like we're doomed with this cheaper, the tools we have, so limited. We can experience and that's it. Like, there may be art. That's why so many things we just can't reduce it, can't really study in a social scientific way at all, or scientific way, whatever way it is. Do you think?
Yeah, I agree. Yeah, but I think it goes back to what Michael's saying. But what do we do to go beyond those bounds? And yeah, I think that's why I think the phenomenological mind investigations in those areas are what is the nature of experience? What is the nature of awareness? The emptiness and nothingness and these sort of things. I think that these are this is the fundamental reality, but that we can't really say too much about them, and so that in a sense it makes them, subjecting them to sort of like Western scientific methods. It's kind of missing the point, because they're not the right things to use when you're trying to investigate those things. And I think this is in the golden period of Zen, this is what the monks, they were all trying to investigate this thing. What is the nature of reality? What is the nature of mind? And not in an individual sense, but mind in one mind. And they were developing phenomenological methods, well-established phenomenological methods that we still use today in order to explore that. It involves going beyond the intellect, and the science is based on the intellect. So it's confined within that. And so what this is pointing to is beyond that. And then maybe most people wouldn't be interested in that, because there's a whole industry around the intellectual pursuits and intellectual fruits that science produces. So in that sense, the presentation is probably irrelevant to most people. But I think hopefully these thoughts weren't naive to you, or that they may have resonated in some way. They were certainly meant, I presented them as seriously as I could.
I love it. I want just to restate, I love your talk. And as always, but also I think it's relevant. I guess maybe, sorry, I use 1 minute to even my own experience. I didn't seriously think myself as a social scientist, what's my philosophy stand, my position, until I was taking this inquiry of scientific questions, a formal course during the first year of my graduate school. But then I was realized first time in my life, I need to be serious about my take, my stand before I can do anything. But then of course I have to carry on because I'm changing too. I have changing stance sometimes. But it actually is interesting. I want to miss a very practical question related to you talking about whether we should have medication class. And Alex has said we should have content class for social scientific disciplines. I think it's all right. It's just we're so limited, and because even for that class, made me realize how important to secure my own stand. It's maybe the only one in my discipline that offered such a course formally in my discipline. So I feel it's just maybe a failure. So I feel the practical idea about what you presented today is that everyone have to think about this. Maybe we have some limitations about what we can do about it, but we need to know, well, what we do has so much limitations. I guess at least to me, that's very important.
Well, I guess, just to add something on that, there's limitations. My hope, I didn't state that in the talk, but my hope really for quantum cognition is a real growth area, is to provide fundamental theories and also empirical methods to explore the phenomenological mind in a way that's different to the meditative practices. Because if it's right, that certain results suggest, that things are beyond realism or beyond the conditions of a realist point of view in terms of experience, if we can get empirical hold of that, then we're of experience. And I think going forward, I think the computational mind can't deal with experience. Yet the human being, so much of us has an experiential realm that the computational mind can't get hold of. But we need some theories and empirical methods in order to try to investigate and explore the experiential dimension of the human mind and the human being, not in an individual self, but how it interacts with the environment. And I think that quantum cognition my hope would be to contribute something in that area. But maybe I'm crazy, so, that could also be true. Based on the subject I presented, maybe you think that, but anyway, I'm serious about what I just said.
Thanks so much again, Peter. As a final word, maybe the comment of Matt, I think is appropriate. Our limits may be a blessing because they teach humility in a hybris-filled world.
Yeah. Yeah, I agree. Yeah.
And Peter,
Okay.
before you go, I want to just highlight one chat again from Hilary Wesner from the chat. Just echoing what Catherine and Drew said, what a profound, clear, valuable, and useful communication about how to approach these questions. Many, many thanks. So
Okay.
hopefully you have a good drawing tonight.
Yeah, thank you. Yeah, and thank you again for inviting me. I really like the presentation that Michael gave, and I think that it's really wonderful that this forum is so eclectic, and you allow me to present these sort of things, because there's not many forums where I would dare to get up and talk about these things and feel comfortable sharing thoughts that are still in progress and maybe incoherent in many ways, but at least that it seems like this sort of forum is very open to different things, and I think it's great.
Well, we're glad you
Thanks,
came, Peter, and joined
thanks,
us.
Alex and Michael and Joyce for organizing this thing, because I think there should be more of these sort of forums, I think. Yeah.
All right.
Thanks so
Well,
much, Peter.
10 minutes or so, and then we'll see
Yep.
Dominic Widows.
Yeah. See you later.
Hopefully.
Good night.
Good night.
Good night.
Okay, let's write him an email because he hasn't joined yet. Yeah, are we still recording? Maybe we should pause.
It's a
Sorry,
still
I'll hit stop
recording.
record.
Okay, let's contact Dominic.